Good afternoon, class. Thank you. You can sit down. All right, then in today's lesson, we are going to look at the revision exercise that you were given. First part of the exercise you didn't complete on group work, so it's questions 27 and 28. And then the individual work that I gave you, questions 1 to 4. And then after that, we are going to start a new topic for this year, which is on trigonometry. All right, first question, question 27. The chord AB is 7 centimeters from the center O of a circle. If angle AOB is 104 degrees, you have to find the length of AB and the radius of the circle. Anyone with an answer to those two questions? Anyone with an answer to question 27A? Okay, Gabriel?
The length AB is equals to 17.96 cm.
And B, the radius?
Radius is equals to 11.4 cm.
Okay, very good. A 17.9, the length of AB, and B 11.4 centimeters. Right, question 28, AB is a chord of length 12 centimeters in a circle, center O of radius 8 centimeters with AC as the diameter. Find the distance of the center from the chord AB. Siegfried? Question 28A. Pastor Mike. Where's the other one?
AB is 5.29 centimeters away from the radius.
Okay. Anyone with answer to B, the length of BC? Then, Pastor Mike up.
(10.58 to 2 decimal place).
Right, 10.58 to 2 decimal places, 10.6 to 1 decimal place, correct. Letter C, anyone else for letter C? Honrele. Pastor Mike.
5.9 centimeter.
Okay, 5.9 centimeters, 6 to the nearest whole number. And D, Gabriel. The area of triangle ABC.
63.6 square centimeters.
Good, 63.6 square centimeters. Okay, the next work was the individual work that you were given on geometry. Question 1. Any volunteers to answer question 1? Miriam, you have to give the angles X and Y.
Angle X equals 109 degrees and angle Y equals 127 degrees.
127 degrees. Anyone disagree with Miriam's answer? No? Okay, good. Question 2. The rhombus ABCD. In the rhombus ABCD, find the sizes of angles DAC, BCD, ABC, and DOC. Anyone? Daniel.
A equals 116 degrees and
That's
B
DAC. Is that angle DAC?
no Number
Huh? Which one is this one? Sorry. Is that number 2? On your, okay, we'll do number 2 on this one. That's question 3 on your worksheet. So this one first.
65 degrees.
DAC is 65 degrees. Next one,
BCD equals 130 degrees.
130.
30. Yes.
Next,
ABC equals 50 degrees.
and,
DOC equals 90 degrees.
okay, BOC is where the diagonals intersect, so it should be 90 degrees. Sorry, DOC. All agree? Right, next one. The figure shows a parallelogram. Write down the sizes of angles marked A and B. Anyone wants to answer that question? Garonamo? Very easy. A is equal to, faster Mike.
A is equals to 116 degrees. B is equals to 64 degrees.
Number 4. ABCDEF is a regular hexagon and ABXY is a square in the same plane. Calculate the size of the obtuse angle CXY. Megan.
Angle CXY equals to 105 degrees.
105 degrees. Anyone disagree with Megan? No? Okay, any questions on those questions 27, 28, and 1, 2, 3, and 4? No? Okay then. Question 4. All right, I'll just do question 4 on the board. Is that how the diagram is labeled? A, B, C, D, E, and F, A, B, X, and Y. You all know that in a regular hexagon, each of the angles inside is equal to 120 degrees. Okay, you all know the formula, 180 multiplied by 6 minus 2, which is 4, divided by the number of sides. That will give us the angle. Okay, you are asked to find angle CXY, which includes 90 degrees because it's the angle in a square, and then these two are equal. This is 120 degrees, and this is 90, which gives 210. You subtract 210 from 360, and it will give 150. So this is 150, but because it's a regular hexagon and it's a square, the lengths are equal. So 150 plus this one is going to be 15 and 15. Because 150 plus 30 will give 180. So 15 plus 90 is 105 degrees. So angle, what is it? CXY is equal 90 plus 15. Clear? Okay. All right then, if there is no more question, we'll go on to the new topic which is on trigonometry. I'll just explain a little bit. What we will do is to use the sine rule, sorry, not the sine rule, the sine ratio to find lengths and angles of right angle triangles. Okay, trigonometry concerns the study of angles. It is used to find the distances that are difficult to measure. Okay, the study of trig that we are going to look at this point will only involve the right angle triangle. When you do grade 12, and I don't know if we'll start it this year, you will actually solve triangles which are not right angle triangles. You will use other rules in trigonometry that you're not going to use it. Well, I don't know if we'll do it in grade 11, but you will be able to solve triangles that are either scaling triangles with no right angle and also triangles with angles greater than 90 degrees. Okay, but at this time we are going to start from what you should know. The start is what you should know from grade 10. Okay, so in a right angle triangle, we all know the longest side is called the hypotenuse. Okay, if you consider any angle theta, which is bounded by the lines OA and OB. Okay, from a point P, we draw a line which is perpendicular to the line OA, and we call it PM. Okay, sorry, the perpendicular line meets the line OA at M. Okay, then the ratio MP over OP. Note these are ratios. You can write them as fractions. You can also write it as MP is to OP. It's a ratio. So the ratio MP over OP, which is MP over OP, and OP happens to be the hypotenuse of triangle POM because it is the longest side. So the ratio PM or MP over OP is called the sine ratio, or it's the sine of angle theta. Okay, the ratio OM, which is this side, and it happens to be the side that is adjacent to angle theta. The ratio OM over OP, which is again the hypotenuse, is called the cosine of angle theta. And the ratio MP over OM, and MP happens to be the side which is opposite to the angle, and OM is the side which is adjacent to the angle. So the ratio MP over OM is called the tangent of angle theta. Now we can have fun. Okay. Usually it is written in short form like this. Sine of angle theta, which is this angle, is equal to the side that is opposite it over the hypotenuse. Okay, so sine, not sin. Some people pronounce it as sin. It's not sin, it's sine. It's just denoted with sin. So sine of angle theta is equal to the opposite side over the hypotenuse side. Cos, which is for cosine, cos of angle theta is equal to the side which is adjacent to the angle over the hypotenuse. And tangent, tan of angle theta is equal to the opposite side over the adjacent side. Okay, before you do the exercise, I'm going to give you some examples, 2 examples. We are going to use the ratios first with using the sine ratio, and then the cosine ratio, and then the tangent ratio. You will note that you have to have a calculator. We are no longer going to use tables. That's what you did in grade 10. You have to have a calculator. All of you have different calculators, and I'm not someone who uses very complicated calculators like some of you have. I have a very simple one because I don't use a calculator often. I prefer to exercise my brain, so I stay young. Okay, we'll do, but for 3, you need a calculator. Know how to use your calculator, don't ask me, because you're supposed to. I didn't invent calculators, so I don't know how to use all of them. You have to read the manual and see what you can do. Okay. To use the sine ratio, because you will have to take note that because sine involves the opposite side to the angle and the hypotenuse. Anytime you are given the opposite side and the hypotenuse, then you have to use sine. That's how you work out which ratio to use. Okay, if I have this angle 22 degrees and the side opposite it is A, and the hypotenuse is 20 meters. To find the side A, since A is opposite the angle and the hypotenuse is given, I will have to use the sine ratio. So sine of angle 22 degrees is equal to A over 20. Okay, using your calculators. You have to multiply 20 by sine of 22 degrees. Or you can find sine 22 degrees, get the answer, and multiply it by 20. Anyone who's found it? Solomon?
7.5 meters to 1 decimal place.
7.5
meters,
and that is to 1 decimal place. All of you agree? Did you find it? Okay, now we are going to find the angle theta. Okay, first I have to say sine theta is equal to 30 over 45. You divide 30 over 45, get it into as a decimal point. 666. Okay, I'll say 0.6667. You can keep the number in your calculator. You don't have to change it to this. And then you then find the angle. You'll have to press shift. Most of you will have to press shift and then go back to sine where it says sine theta or x to the power of -1. Like I said, I've got a calculator that many of you don't have. So if I teach you using mine, you will get lost because that's not how yours works. Huh? 41.8. Do you all know what to do on your calculator? Do you all know what to do? Everyone? You have to know? Okay. Example number 3, I'll draw it on the board. This time I want to find the hypotenuse. Sine of 29 degrees will be equal to 4.6 over x. All right, x will be equal to 4.6 over sine of 29 degrees. So for many of you, your calculators will be able to do this. You get 4.6 divided by, and then I think press sine 29 equals, and it will give you the answer. $9.5. Okay, 9.5 to 1 decimal place. So you all know what to do? Anyone wants me to try? I will probably know how to use this one, which is, what is it? FX82TL. I don't know how to use the others. This is as far as, if you've got FX500, then you are more advanced than I am. So does everybody know how to use this one? All of you who have this, you know how to use this? True? Okay, I'll try. If you want to find a sine 20, you get 8 multiply 20 by sine 22. So you can go 20 multiplied by 20, no, sine 22, and you press the equal sign. It will give you 7.5. Again, you get 20 multiplied by sine 22 equals, if you've got one that is FX82 SL, is there anyone with SL? No? In some calculators, you will have to press the angle first and then press sine. Okay, you will go 20 multiplied by, you press 22 and then press sine and then press the equal sign. Okay, but for this one, you do it just like the way it is on the board here. You get 20 multiplied by sine. Sorry, I should have said that this is, when we don't usually write as multiplication sign. Okay, so it's 20 multiplied by sine 22. Clear? Okay, this one, you divide, we try it first. If we make a mistake, it's okay. 30 divided by 45 equals, and then you go shift, and you go where it says sine to the power of -1. It's on the same key as sine. And then you go equals. You get 41.8. Hooray, I got it right. Repeat. You go to get 30 divided by 45, and then you press the equal sign. And then you go to shift, and then where it says the same sign key, sine to the power of -1, and then you press equals. And it will give you 41.8 to 1 decimal place. Now, we'll just go a little bit further on this one. In some textbooks, I don't know, I'm not really sure about this one. You will have the angles in degrees and minutes. If you want to change this one to degrees and minutes, there is a key that is like this. It's got a 0, and then this, whatever they are, apostrophes. With 41.8 on the screen of your calculator, you just press that one. Press it and it will give you 41 degrees, 48 minutes, 37.13 seconds. Did I make myself clear? Okay, so the first number is degrees, the second one is minutes. Huh? Seconds. Clear so far? We go on to the next one. Okay, this one is x is equal to 4.6 divided by sine 29. That is, you only do this, you listening? You only do this if the hypotenuse is not known. That's when you find that you will divide. I'm talking about using the sine ratio here. Okay, if the other two sides are known, are not known, you will multiply. If the hypotenuse is not known, that's when you divide, because I found out that some students still don't know when they should multiply and when they should divide. So, after I get this, 4.6 divided by sine 29, sorry, 4.6. 4.6 divided by sine 29, and then you press the equal sign. We get 9.488, which is 9.5 to 1 decimal place. Clear now? Okay, now you can do the exercise. Okay, first two questions. You have 10 minutes to do those two. Sine ratio. If the side opposite the angle that you are looking at, and the hypotenuse, if the side opposite or the hypotenuse are not known. No, this one is adjacent. So long as it's the side that is opposite to the angle, it must be the side opposite to the angle and the hypotenuse. Yeah. But this one is not. Which one? No, you can't. Tangent is opposite over adjacent. No, that's the hypotenuse, this x. Because it's the longest side. Yeah, hypotenuse, that's why it's called, it's hypotenuse. It's this side that will be, if it's this side is not known, then you use opposite over adjacent. Because the longest side is the hypotenuse. So you can't use 10 for that one. Although this side is the adjacent to this side, but specifically the hypotenuse. Side not given, or the hypotenuse is not given. So long as the opposite side, if the hypotenuse is not given, the opposite side to the angle will be given. If not, you can use this. You can also use this one and find this angle, and then you can use cos. But that's later. We are only using the sine rule first. Which one? 11.2 centimeters. Okay. This one is 11.2 centimeters. With an answer to number 1, Gabriel.
For number 1, AB equals to 30 millimeter.
To the nearest whole number.
Yes.
Okay. Some of you have 29.97. Okay. Velma, what's your answer for number 2?
Side A is 28.32.
Okay. AB is 28.32 to 2 decimal places. You all got that? Okay. For homework, you are going to do questions 3, 4, and 5. And that's it. 3 questions for homework. The shortest homework I've ever given. The keyword to the pilot teacher is sine. All right, stand up. Good afternoon, class. Thank you. You can go for your next lesson.